Hi, thank you for the introduction. I'm David. I will soon be a 3-time dad, and you can't imagine how proud I am of that wordplay. I'm talking about wrapping cargo for shipping. I will soon explain what I mean with that. I spend a lot of time researching on how applications these days are packages, on how they're bundled, how they're distributed, and how they're executed, and what their execution environment looks like on the different platforms we have today. And especially, how can we apply this to Rust? And the question I had is, can cargo emit application bundles, and especially, should it? Before I dived into that, I reviewed my own way of installing applications, the applications that I use every day. And I have a brother who does graphics design, and from time to time I've spent time with him working on different projects. And if you install software and you're working on graphics design, what you're doing is you go to the Apple Store, for instance. You download the software, you use it, you can work on your projects. You have multiple softwares to work on the same files. It's all fine. I'm also a sports coach. I teach students how to play Ultimate Frisbee. With my colleagues, I prepare drills. These days, you use software for that. Of course, where do I go? For the tablet, I go to the Play Store. I download software I want to use. I'm also German. I need to deal with German bureaucracy, and that means from time to time you get a docx file sent to you, and you somehow need to print it and sign it. So I also deal with the Microsoft Store. And in my personal life, it's the same thing, but I don't use these stores. We have something else on Linux devices these days, work the same way as FlatHub or SnapStore if you're using a canonical machine. But lastly, I'm also a software engineer. I fell in love with Rust. I use it every day. So what do I do to get my software work when I work with Rust? Where do I get my tool chains from? Well, this is what I use. So why is this different to the things I use for everything else in my life? Well, first of all, let's fix these short options. I really don't like these. I never understand what they are for. Much better this way. I'm not interested in the security model of this. I think it's fine. You can discuss that. It's not the topic of today. The reason I think we do this is mostly social reasons, because it's our ecosystem works and has worked for a long time. But I think we're not leading with a great example here. If I tell a graphics designer that this is how they get their software to work on graphics, they will yell at me. They will not do that. And I can ask you, would you do that? Would you install your Netflix client that way? Very likely you would not. So why are we OK with the other one, but not with that one? So my personal reason, or the reason I found resonated best with me why Rust does it that way is that it tries to trick me into a personal relationship, right? It tries to build a trusting relationship and tries to lure me into dealing with the system and ideally contributing back and working on Rust. And it's totally not worked. But if we ignore Rust for now, what are all the other ones? All the other ones have in common that we use application bundles. But what is an application bundle? It's not a real term that's defined in a sense. But for today, I try to concentrate on an app bundle is whatever is left on your device after you installed it from one of these stores. So if you look, for instance, at Android, when you install something, what ends up on your disk is the right side. It's an APK, an Android package you get on your disk. For all other systems, you get a directory where everything is unpacked of your application onto your device. So an application bundle usually is a more or less structured subdirectory somewhere on your machine. On the left side, you see what is the application package. An application package is what you upload to the store, what you provide them. And in most cases here, they use fancy file extensions that are nothing more than a zip file of the directory, more or less. Linux is one exception here. Like, they have multiple solutions, of course, as they always do. They have Flatpaks, they have snaps, they have app images, and some of them work differently than the others. But I will ignore these details here. The takeaway from that is, if you're developing for Android, for iOS, for macOS, for Windows, one of these major platforms, these application bundles are mandatory. They are the default, and they are mandatory. You have to deal with them if you're writing software for these applications. But these applications bundles haven't always been a thing. Windows, back in the days, you had scripted installs. The way you installed software initially is you would pass a script around and give it to users. They would execute it. It would install your software. All fine, you would think, but it was a horrible mess. The thing could do anything on your system. It was soon replaced by Microsoft by something called MSI, the Microsoft installer. The idea was nice. You have a description of your application, a declarative approach that says, these are the files I have in my zip files. Please store them on the machine. Please also add these registry records and do this kind of system integration. They also added a feature that allowed you to execute something on install, a custom script, a custom extension to do something else. 5 years later, the official Microsoft Office installer was nothing more than a custom script inside an MSI file. So this was a huge mess. It doesn't really work. There's this famous company, Affinity, which publishes creative software, and they said their MSI installer success rate was 85%. This means 50% of their installs failed. And I think it's just mind-boggling. And then comes along a company called Softricity and creates something called App&Web, which is later on bought by Microsoft and labeled App Virtualization. I don't know if anybody heard about that before. It was developed in 2006, 18 years ago. What they did is they allowed a client device to be pretty dumb and just have a shortcut for applications. And when you start an application, it would stream it from a server onto your device. You would execute it. You could edit files and so on. When you're done, it would clear your device again. There's nothing left on your device for that application. It was really neat. It's very nice for managed devices and for managed networks. The problem they had is they couldn't just send you an installer, right? They couldn't send you a script you execute on your machine. They needed to know what is the application made of, what do I have to stream on that device, what do I have to clean up after I'm done. They created this App&Web technology in 2006, and Microsoft bought them, and the way it works, they didn't update it at all, but developed their own. So very few people know of that these days. But 6 years later, in 2012, Microsoft created something called AppX, which is basically MSI, but they got rid of all the scripted installers. And it forms the basis of the Microsoft Store these days. Again, 6 years later, in 2018, Microsoft created MSIX, all right, which is an extension of App&Web, uses the old name but has little to do with it. This is basically the base technology these days. This is what you use to create an installer, a fully declarative installer that is reliable on Windows machines. So 18 years, Microsoft silently introduced an application model for the Windows platforms. We went from scripted installs to MSIX. Everything is reliable. It's nice. You have a sandbox for your application. It's virtualized. You get a virtualized registry, a virtualized file system. Perfect. That's exactly what you want as a user for your applications. And then Rust comes along, and they're like, yeah, please download your scripted installer from here. We are really harsh to Microsoft sometimes. But it's not just the Rust developers that deviated from this model. Developers in general are very skeptical of this. But I think the important part here is to understand why all these platforms use this, is you have to think from the user's perspective. For user, an application model and these application bundles are very, very useful because they guarantee you that you get isolation between applications. You get sandboxing. You don't have to trust the application. You get determinism. You can get a reliable uninstall of an application. You get dependency management, basic dependency management in a lot of these models as well, for free. And for users, it means you don't get an auxiliary search toolbar in your browser installed with the software you actually want, and you don't have to wait 15 minutes for an uninstall operation. So what these app models do, they limit developers by design, but they empower users. They give users much more control. And the application no longer controls the system, but the system now controls what an application does. And we as Rust developers, I think we're very accustomed to this model of giving up specific freedoms to gain determinism and to gain safety. So what's the status quo in Rust? When you're developing Rust, you're using Cargo, like everybody is. It's a standard in Rust. But Cargo operates on the process level, always. Like the most elaborate thing it can output is a binary. You can also output a library, of course, or an object file, or like some intermediate. But the most complex one is a binary you can execute. And there's no real reason for that. Like, sure, the ecosystem works that way. Go does the same thing. Other languages do the same thing. It's what we are all accustomed to, but there's no technical reason to do it. Like, Cargo could very well just output an object file and tell you, yeah, here's your object file. Do with it whatever you want. And we have to understand, if you're an application developer and you're dealing with application bundles from day to day, it feels the same for you. Whether it outputs an executable or whether it outputs to you an object file, it doesn't matter. You have to post processes into something you can then use on that machine, you can execute. However, it's very convenient for us. We're used to it. Like, a lot of time we write small executables, we're so used to just execute them in place. We test them in place, we're used to it. And it's very, very hard to change that. But it's also something that is very, very fragile. We always think we have a well-defined execution environment when we really do not. We don't know where we are running. We don't know what the environment looks like. We have no generic access to the system. And if you just imagine you put in a wrong recursive file removal into your software, and you test it, and you pass the wrong file descriptor to it, and suddenly you ruin your entire your entire system or your entire user database. Tell that to somebody who's not doing software development. Tell it to a graphics designer. If you have here a software, you can draw all kinds of shapes, but if it's a circle and it's red at this coordinate, your system is ruined. Nobody would accept that. Nobody, except we are apparently completely fine with it. And all of this is not a problem for app bundles. App bundles solve exactly that. They try to give you a way to create an application and that you can execute in a controlled and deterministic manner. We have stopgap measures in place. Like these days, you can use containers. You can use something called bubble wrap, which is effectively a container to execute your applications. And they will prevent most of the errors, but they are stopgap measures. They are not integrated into a system at all. And it's very hard to fix this ecosystem. I believe we can change Cargo. I believe we can change Cargo to give us something better, to something we have more control over. But even if you do not agree, you have to understand that out of the most, like, we have 26 million developers in this world. And the majority of them, like, the minority of our software is targeted at just these 26 million people. But most of the software we write targets all the other people in this world. And every developer who writes software for these people needs to deal with application bundles every day. And we make it really hard for them to do that, because Cargo cannot emit them for you. You have to do all that yourself. So what we try to do is, can we make Cargo better? What can we do to help, like, to cater to these people, to these developers, so they can make it a lot easier? So this is the second part. How can we wrap the current Cargo as we have it and make it so much easier to use? The first thing we did is we looked at the status quo. What are people doing right now to get application bundles with Rust code? And you can look at the different platforms. What they do is they use the native toolchain. If you're developing something for Android, you use Android Studio. If you're developing something for Microsoft, for Windows, you use Visual Studio, and for Mac Xcode, and so on. And we looked into these because it's very easy to use them, because they support the platform and the full configuration of the platform. What can you do to ensure that you can use Rust with these projects? And this is not from us. Like, we tried to work with them and encourage people and collect information what people do. So if you're, for instance, developing on Android, there's something called Rust Android Cradle. It's an integration into the Gradle build system, which is the build system used by a lot of Java projects. It's published by Mozilla. They use it to build Firefox, I assume. So you can use it to call Cargo from your Android Studio build. For Xcode, there's something similar. It's called Cargo Xcode. It's a community project that generates your Xcode project files. So you can have your Cargo project, build it separately, but pull it in as a dependency into your other Xcode projects. We worked with the Meson build system to make sure that Meson can build Rust, and we invented something called Meson Cargo to ensure that you can make build app images, flatpaks, and snaps because they have Meson support, and you can pull it in this way. These days, Meson actually was lobbied enough to get upstream Rust support, so this might not be needed in the future. And last but not least, if you have a pure CMake project, there's something called corrosion, which allows you to do something similar. Crucial to understand is, this is the status quo. If you see like an application that is more than just an example application, in the wild, they use one of these solutions, very, very likely to get your Rust code into production, onto consumer devices. And the advantage here is that you get a full scope of the platform configuration. Like Android Studio supports all options you probably likely want to use on Android. And it's very easy to please the app stores, because they do things exactly right, that the App Store will not complain about the way you build your applications. But the negative side here is it's a heavy buy-in into the platform. You're dependent on them. You can't control them. And it's inherently non-cross-platform. You have to know each of these individual tools and how they work to actually get your application in each of these platforms. Often, Rust is also delegated to background tasks. It's very hard to do UI when you're integrating with these tools. You can do it. It's possible, but it's not very simple. Last but not least, these are very, very unpopular. If you look at the Stack Overflow developer surveys, Android Studio, Visual Studio, and Xcode are the least popular tools amongst developers by far. Like less than half of the people who use them are looking forward to using it again. So we don't want to force people to use into that. It's fine for a big project. It's definitely not a solution for a small project or an ad hoc execution. So what if we ditch all these requirements of supporting the entire platform? What if you just say, how far can we get? How many benefits of applications can we get with Cargo? So what would that mean for Cargo? What would Cargo have to emit? Before Windows platform that now look at the macOS platform, this is actually what an application bundle looks like on macOS. You have a directory that is suffixed with .app, and that's it. That's enough. The platform will treat this as an application. And now if you want to do something useful with it, you create a directory called contents, and you put in a manifest file, which is a plist file on macOS, and you put in your executable into the macOS directory. There's some other things you can put in there as well, but the bold content is enough that you need to do to get an application bundle and benefit from most of the things that the application bundles give you. This is very similar on other platforms. Very often it's just a directory, dump things in. This should be easy for Cargo to generate, right? Cargo can output things like that. The question is, how can we integrate it in the Cargo? Like, where do we tell Cargo that it's supposed to do this? The first solution that we came up with was, how about a different crate type? You just say, don't produce me an executable or a cdylib or whatever, produce me a bundle or an application. The problem here is this is very much tied to Rust C and to the build target, because crate types, like application bundles, allow you to do much, much more than what a single crate allows you to do. And by tying things to a crate type, we would not be it would not be possible to do all the other things that these bundles allow you to do. So what you did instead is just, in your Cargo demo, how about you just say you want an app? You add a new Cargo target to it. You give it a name, just like a bin or a lib target. You have your entry point file. That's it. Should be very simple to do. The downside of this approach is it's very intrusive. Like, you have to do that everywhere where you want to take advantage of this. It's not homogeneous, because a lot of the configuration keys you would need for your bundle later on, they are specific to the bundle and do not really apply to other targets. There's also this possibility of creating an application bundle that has multiple architecture compilation units in a single bundle that can run on multiple architectures. This is not common for other Rust targets, like you can't do that with a lib or so on. And last but not least, it would require a lot of toolchain applications to build the actual applications. Still, it works. Like, you can do it that way. It's a fine abstraction, and we can build it. And that's why we tried it. But there's one more thing. We didn't want to extend Cargo right in the beginning. We wanted to play with the extension points that Cargo has. And Cargo is very nice in the way that it allows external applications to extend cargo, and it has JSON communication channels that you can use. So we didn't exactly use this syntax, but effectively something very similar using the package.metadata key. What does it look like if you do it that way? You would simply type in cargo build --app instead --lib, and you would build your application bundle, and you could run it, and you can package it. The packaging part is not that interesting in that because it's just post-processing of it, so we ignored it for now. This works. Other people did that before. Like, we are not the first one trying to do that. But what we did with that is we tried to build it in a way that we extend cargo so we can piece by piece take the individual things that we added and move it into cargo. So ultimately, there will be a way to get this into cargo. What we called it is Osiris, which is the project name. This is how you invoke cargo extension modules. So unlike the previous one, this one will require you to actually extend cargo into something. This one is how you call cargo extension modules. But effectively, from a user perspective, it's the same. And it works. This is you can do that. It doesn't support all platforms yet, but we have figured out how to do it on all platforms, and we have proofs of concept for all platforms. So the question, is this the future? Is this how we want to do normal applications in cargo in the future? And there, I'm not so sure. Because while we can definitely do that, and we're ignoring packaging for now, while we can definitely do that, and it works, there are a lot of problems that we had to face, which I want to talk about next. And the first one is ad hoc execution. And this is actually one of the most crucial problems. If you create an application bundle on a platform, you're creating it in a subdirectory in your target directory, probably, somewhere in your project files. And if you want to tell the system, please execute this application bundle, most of the systems go out of their way to prevent you from doing that because they don't want you to execute just an ad hoc application bundle that you have, but install it on the system. The Flatpak system, they just say it's out of scope for them. You're not supposed to do that. They don't support it. On most other systems, you can get away with it, but it's certainly ugly. On Windows, you have to install the application on your system before it works because it needs to be discoverable in your start menu to actually give you all the access you want. macOS is basically the only platform that allows you to do this ad hoc. On all other platforms, you get remnants on your system when you try to run things that way. The other problem that we had is local configuration. How can we extend cargo, but in a way that we don't add our own configuration to it? And cargo has this neat thing called package metadata, where you can extend your cargo.toml file with all kinds of metadata. It's up to you what you do there. But this is project configuration. When you have local configuration, like I'm trying to tell a tool where it can find the Android SDK, where do we do that? Usually we use the cargo config.toml files, but there's no way to add custom configuration there. You can just add your own keys and eat all the warnings of the tools, but it's kind of lacking. There's no real story how cargo tells us how are we supposed to extend cargo with local configuration. This is not a blocker for this, but it's definitely something that's a bit ugly to deal with. The third problem, and probably one of the biggest ones, is foreign language support, and this is especially on Android. On Android, you have to have Java code as your entry point, and a lot of the code you need stub Java code so you can interact with the system. If you're not dealing with the entry point, you can just compile Java code, add compile time, link it into your application, and load it at runtime via dynamic class loading. But you can't do that with your entry point. So you somehow need a way to tell your build system, hey, this is the Java code, please compile it, please link it into the application. Again, certainly doable, but quite ugly. And if you do it correctly, you end up with a Java build system inside of your cargo tool, which definitely is not something you want to do. The other platforms do not suffer from that. Like if you need native code there, usually you have an alternative in doing things Rust only. Or you just use build.rs to build your applications. But this is certainly an issue on Android, and it's not easy to solve. Number 4, multi-binary compilation. If you have an application bundle, it's more than just a single executable. In an application bundle, you can have multiple executables. You can have tools inside of it. You can bundle your libraries. You can bundle external applications. And you can even nest application bundles one to the other. But how do we do that? Like, how do we give the user the freedom to actually tell us this is what they want? And there's a neat feature in Cargo called bin deps, binary dependencies. It's an unstable feature, but it solves all of this very neatly. And we're looking forward to stabilizing it, but so far it has not happened. What binary dependencies allows you is when you specify a dependency in your cargo.toml, usually what Cargo does, it compiles it as an rlib and links it into your application. But with this feature, you can say, don't compile it as an rlib, but compile it as an executable, compile it as a shared library, whatever. This means Cargo does this and then ignores it, so it no longer tries to link it in any way. And we can use this, so the user can use bin deps to specify what makes up a bundle. And we just have to follow along what Cargo build actually produces and copy everything that the compilation produced, copy into the final bundle, and we're fine. But this leads to number 5, artifact filtering. How do we know what each artifact actually means? Cargo, as I said, Cargo tells us when it's building, it tells us which are the artifacts that it produced. But it doesn't tell us what this artifact actually is. So it doesn't tell us, is this like an rlib? Is this a dynamic library? Is this a debug symbol file? We have to rely on file name parsing and file extensions, which is doable, but certainly ugly to figure out what each file is supposed to mean. And there's a feature in Cargo where you can rename your output artifacts. And if a user does that and renames things using reverse domain notation, for instance, it's very likely to conflict with file extensions. So it's currently really, really hard to do this reliably with Cargo. We opened a PR. Hopefully, we can fix this. It should be an easy thing, but it's currently kind of a blocker to get this working reliably. But the biggest one and the last one is platform stability. All the different platforms make it really, really hard for external tools to do that, either because they're not documenting how to do it, or they're not releasing required tools to actually do post-processing for your bundles, or they're changing their requirements all the time. And I think this one is the most crucial one where we need a lot more work, where we need to talk to these different platforms and ensure that they allow us to do what we are doing, and so we don't break with every platform upgrade. So as a summary, yes, Cargo can emit application bundles, but with a big maybe. A lot of people have tried this before, and we tried to consolidate all these efforts. And there's still major questions left how to do this, in a release build, how to give this to users. We certainly believe that Cargo should do this, because there's so many benefits. It's so nice to get application bundles instead of just plain executables, and to get a reliable environment where everything's executed in. Our priority has been to document this process, to create a reference documentation that explains how can you create these bundles on each individual platform, so developers can play with it. The second thing is we try to talk to the different platforms and get them on board, and make them aware that we are trying to do this, and ideally get these platforms to support this way of building these applications bundles. And hopefully in the future, this is hard with Apple, of course, it's hard with Microsoft, but we know people inside of Microsoft, we know people inside of the Linux distributions and so on. And they are all open for that. They're all just looking for people to actually do this, and people to play with it, and find a path forward how we can do this. This is all developed as part of the Osiris Project, so go to the website to check it out. This sub-project is called Osiris, but you usually find everything under the term Osiris. Yeah. Thank you.
Okay, let's take some questions for David. Who wants to go first? Cargo person?
So you mentioned that at the beginning that there were other tools, but it's like per platform you have to do like a very specific process for that platform. But I didn't see a mention of Crab Nebula's Cargo Packager or Axolotl's Cargo Dist. How does this compare to either of those?
There are lots of tools to that deal with this problem. Like, it's not something new, as I said. I know best the way that Flutter does it, and I think those two tools do something similar in that way. They try to automate the process to integrate with all these platforms, to integrate with Android Studio, Visual Studio, and so on. But what they output is usually the build configuration files for these platforms. So they make it a lot easier to do cross-platform development for these platforms, as long as you don't have to change specifics for these platforms. So the input configuration is not as powerful as you would often wish. And so if you're doing a more complex application, you have to know, how do I extend this Gradle file to link in whatever third-party tool I need? How do I extend this Visual Studio file to give me the right permissions on the platform, and so on? So in that sense, they try to automate the process that I showed individually for each individual platform, but they still very often require you to know these platforms to do something that is more complex.
Have you actually communicated with them about integrating your techniques or any kind of collaboration on those efforts?
Not with these two. I actually don't know. Cargo Dist, I'm not sure.
Cargo Dist, it's a whole release pipeline process. Once you've tagged a release, it'll take care of everything else.
Right. Yeah. There's a big, yeah, okay. We've talked to several projects. The Tauri, for instance, are people who did a lot of work that I wrote it somewhere down. The biggest issue here is that a lot of these projects try to get things ready as soon as possible. Like, you give developers something to their hand, which is a very valid approach. Like, how can developers do this now? But we try to do it in a way so we can contribute back to Cargo, or at least do it in a way that can be integrated into Cargo, or explore that space. So that was a major difference there.
So actually, Crab Nebula specifically has been looking. They actually have talked with the Cargo team of what would it take to get this into Cargo.
Yeah.
So it sounds like there's room for potential collaboration.
Certainly, yes.
Okay, next question.
Hi, so you were talking about platform instability. How unstable are these platforms? Does it change every month, every year? And which platforms are the worst offenders?
The biggest offender probably is macOS. Very often you can make it work, but they drop support for old platforms and make new things mandatory. Just, for instance, talking about the architecture you're using, they're supporting, I think, the Intel platform compatibility layer for 2 years, and then it's done. Android has a problem that is the least introspectable. It's very hard to know what they are doing, and they have been moving away from APKs, at least for submission, to Android app bundles. And they're doing quite a complex thing there. It's very hard to integrate. If you're following their official model, very often it's compatible for a long time, but if you're doing things differently, you often don't know. Like, again, Android, they have a tool called Manifest Merger, which allows you to take multiple Android manifests and merge them, which you have to do, like they do it, but they hide it from you. They document how it's supposed to work, but the tools themselves, they can change all the time because it's released together with the build system. So though we don't know, it's likely to break easily. The Linux platforms are easier to work with because they tell you you're supposed to do that. So yeah, I would say the biggest offenders is Android and macOS.
Okay. Any other questions?
How does this deal with different kinds of trying to think of how to phrase this, but like dealing with different multiple assets and multiple forms of assets. So you can have like a binary, you might have some plugins to go with that binary, you might have man pages or shell completions, you might have asset post-process that needs to go on. How does it handle those kinds of things?
So our proof of concept, I don't know, is that mic on? I'm not sure whether everybody got the question.
be.
Yeah, perfect.
Make closer.
Hello.
Yeah, perfect. It was quite silent for me, but all fine. Our proof of concept tried to do exactly what you are describing. Figure out how each step is done on each platform. So you could compile assets, you could compile resources, you could get them all in a way that are supposed to be on the platform. They vary a lot between platforms, but there are concepts that are available everywhere. For instance, the concept of just a pure asset that is not touched at all, every platform has, like you can put in files. The concept of resources, which can be looked up based on locale, so your language and so on, exist on all platforms we had to deal with. So these could be abstracted. The question there is not about how to do, like you have to use the tools provided by the tool chains of the platforms. It's very hard, like you could do it yourself, but often it's not documented and so on. The biggest issue is how to expose it to the user if you're doing it cargo.
That's what my question basically is.
Yes, exactly. And that's I shortly mentioned that when I said moving from toolchain, like from using the native toolchains to moving to using cargo, like we dropped all this as an initial step. We said, okay, we're not trying to target all these individual features of a platform, but instead we do it that way. And then later on individually added more and more pieces. So for instance, we added via package.metadata a way to specify an icon and different icon sizes you have. You can specify a directory of assets. We didn't do resource compilation in that sense. And the bin depth feature allows you to do that for all kinds of compilated units. Preferably, we would have that for build.rs, that it can also generate things, and Cargo will announce it as a compiler artifact. So we get this as well as an input. This doesn't currently work. Any further steps there are open to explore.
All right, thanks.
All right, thanks. I think we're just in time for the next speaker, so thank you very much, David. Okay.